Good morning, everyone, and welcome to today's webinar. It's QIF 201, Reviewing QIF Technology with Daniel Campbell. Slide, please. Thank you. Some housekeeping today. We will be having you in viewing mode only. You'll be able to ask questions. You'll be muted during the presentation. On your panel, if you can see, we took a snapshot of the panel. You can ask questions there, and at the end, we'll go through the question. We'll do a question and answer session to review the questions you have. And we will be, at the end of the presentation, also sending you an email with today's webinar presentation and the PDF of the actual presentation slides. And today's speaker is Daniel Campbell, who is Vice President of Model-Based Definitions for CAPVIDEA, and he's also a board member of the DMSC, who is the sponsor for QIF. Daniel?
All right, yeah, thank you, Ray. Well, thank you, everybody. Thanks to everybody for joining today. So we're going to be going over, well, hopefully you were able to catch last week's presentation given by Curtis Brown, the president of the DMSC, which kind of gave an overview of the purpose of QIF, the vision for QIF, and basically the problem that QIF is attempting to solve. In this presentation, we're going to be going a little bit more into some of the technical aspects. It's still going to be pretty high level from a technical point of view, but it will be looking into the design of the schemas a little bit, and a little bit about what some of the different application areas are and so forth. So with that, let me give a little bit of background about the Digital Metrology Standards Consortium, the DMSC. The DMSC was the pedigree goes back to 1983. It's been an important body in the standards world for some time. It works on standards in the digital and model-based quality area. Lots of quality experience in the DMSC. It's the maintainer of the DMSC standard, which is a pretty old and well-known standard. And of course, it's the developer and maintainer of the QIF standard. The DMSC is an ANSI accredited standards making organization, and it's also an A liaison member of ISO TC 184 SC4, which is a body that we're working closely with right now for the ISO standardization process for QIF. So that's just about the DMSC. But let's jump on into discussion about QIF and the schemas. And so what we'll start with is just a little bit of background for everybody who's not familiar too much with some of the concepts of XML and XSD and XSLT. These are the tools that are used to build QIF. So first off, what is XML? XML stands for the Extensible Markup Language. And basically what it is a set of rules for text-based data formatting, for expressing data using text files, basically, in a structured way. And the point of it is that it's very good for human consumption, but really the point is that it's very good for machine consumption, for software consumption. It makes it very easy for software tools to read and write XML. And so that's why XML is kind of a modern choice and that's why we chose it for expressing QIF. There are a lot of tools out there to help software developers and IT people with XML. Tools like XPath and XQuery, languages like XSLT, and then if you just start to Google XML software libraries, you'll have pages and pages and pages of free and open source tools that are out there for reading and writing XML. So a little bit about vocabulary of some of the XML, some of the XML terms that we'll be going over a little bit. First, we have an element. So an element is something like this entire block of code down here, a datum definition element. So here, this top line is sort of the opening of that element, and then the bottom line signifies the closing, the end of that element. And so everything inside of that expression is this datum definition element. Then we have an attribute, which is just another piece of data expressed using a different syntax, and it will usually be a simpler form of data, like an integer, like we're seeing here. And of course, an element can have elements inside of it. So here we have a child element called a datum label, which is contained inside of this datum definition element. So, these terms, element and attribute, we might be using these terms throughout this presentation. So it's a little bit of background. So on to this next topic. What is XSD? So XSD is an XML schema definition. Sometimes you might see XSDL, which is the XML schema definition language. XSD is a way to specify a required structure for an XML document. So it will provide the file format that you'll typically see for this is .xsd, and that's the file format that you'll see in the QIF libraries if you download those, or the QIF schemas when you download those. And it specifies what the standard and formal definition for an XML-based format is. In our case, QIF. So we use the XSD format to define what the structure of an XML, or of a QIF format, of a QIF instance file needs to look like. One of the nice things about XSD is it provides a way to carry out validation using standard tools. In fact, standard tools that are available on everybody's operating system. And these tools can check an XML instance file against a schema to make sure that it conforms to that schema. So it's a nice tool for creating robust documents. The other nice thing is about these schemas is that by expressing data in these schemas, it's very easy to automatically generate code, computer software code that can read and write, that will be able to read and write XML files in that particular format. And so actually we'll be getting into that a little bit in the next week's presentation, which will be given by Tom Kramer, where he's going to go over some of the source code bindings that we have made freely available to industry. And these are able to be generated by virtue of the fact that we have these schemas that define the QIF language. So next, XSLT. So what is XSLT? XSLT stands for the Extensible Style Sheet Language Transformation. And what this is it's a Turing complete language for manipulating XML documents. So it's actually a scripting language. And it can be used, so again, it's a standard tool that could be executed on any modern operating system. And in the purpose, or in the context of QIF, it just means that there's further data quality checking that we were able to implement using XSLT. And so in the QIF standard, there are XSLT files that are part of the standard, and they're in the check directory. And the point of these is that you run these XSLT scripts on a QIF instance file, and it'll carry out further validation checking. It'll check things like making sure that references to external documents are valid, or maybe it'll check the length of a unit vector to make sure that the length is equal to 1. There are integrity checks for array sizes, like if you have 300 points, there will be a counter before it that will say that the count is 300, and it's a redundancy check to verify that the integrity of the file is there, things like that. So there's a lot of safety and quality checking that's built into the QIF standard. So that's kind of a quick little crash course there on some of the XML-based technology that's used by QIF. With this, I think, Ray, let's show this this first poll that we have.
Yes. So the first one, quick poll for you, and then you're all, please vote, is do you plan on using QIF at your organization? And the choices are, we currently use QIF. It is in the works, and we don't have any current plans for using QIF. So I'm going to give you a few minutes to vote, and then we'll see what the results are.
Yeah, it's always really interesting to us as developers of the standard to find out, what level people are at with QIF, and also hopefully if you are, currently using QIF or planning on using it, hopefully your organization will consider joining the DMSC as well and participating in the process with us.
So we have about 75% of the votes in, so I'm going to give you a few more minutes here, and we'll close the votes and see what the results.
All right.
Right, I'm going to close it. Oops, sorry. Results are.
Oh, okay. There we go.
Oh.
All right. So we got yeah, some users, and a lot of people have it in the works. And I guess for those that they don't have any plans for using it right now, hopefully some of these webinars will help you out with that for understanding what some of the use cases might be for it. So
hand it back to you.
All right. Well, so on from here, we'll get into we'll start jumping into the schemas a little bit, and into the way the different areas, some of the key elements of QIF. So yeah, into the key elements of QIF, and kind of thinking back to this term elements from earlier in the definition of XML. One of the most important elements, the top level element, is called a QIF document. And this is the top level container for a QIF instance file. So whenever you see a .qif file, you can open it up and you can expect to see a QIF document right there at the top. And all of the data that will be inside of that instance file will be stored inside of that QIF document. Most of the elements, the top level elements that you'll find in the QIF document, or at least many of them, are optional. So for example, measurement resources is going to be an optional element. It's not required that you specify measurement resources in a QIF file. But there's a big laundry list of all these different types of data that you can store at this top level QIF document. One of the most important types, or one of the most important elements within QIF is the category of element that's called a feature. So this idea of features is one of the core aspects of QIF that I think it's very important that everybody understand. The feature is an abstraction. It's meant to be an abstraction on your part, which is used for to reference some portion of the part. And so what that means in the context of MBD or in terms of CAD is it's a way of kind of bundling up one or more geometrical entities in the model in order to specify some portion of the part. So what are we talking about? Maybe you could have a cylinder feature or a plane feature or cone feature, or opposite parallel planes feature, sometimes called a slot. Maybe a free-form feature or a generic feature, etc. Lines features, and so forth. And it's important to the part of the principal reason behind the idea of features is that these are functional abstractions that are especially important from the tolerancing perspective. if you're going to put a position tolerance on a hole, for example, like this item here in the picture on the right, you're talking about a hole. And that, a hole, a physical hole in a part that you're trying to put a position or a size tolerance on. In this model here, I don't know how easy it is to see, but this is made up of two half cylinders. So there's one half cylinder surface and another half cylinder CAD surface. And those two surfaces are what make up the hole. But the fact that it's made up of two surfaces is actually irrelevant. That's just that's an artifact of how it was created in CAD. And depending on what CAD system you're using, it might be made up of one CAD surface or two, or depending on who the designer is, it might have been done in any number of methods. But the point is, it's one functional entity, which is a hole. And so in this case, this cylinder feature will point to two CAD surfaces, and it'll group them together into one functional entity. Then we have what's called a characteristic. A characteristic is a control that's placed on a feature. This might be a size, a form, orientation, location tolerance, a distance between, an angle between, some form of a geometric or dimensional tolerance that might be placed on a feature. It might be a surface finish. It might be a weld specification, etc. The way that a characteristic is connected to the model-based definition or to the CAD would be that a characteristic references a feature, and then the feature references the CAD surface. So that's how this link can take place. Now, with one of the application areas in QIF, which is the product called QIF MBD, it's also possible for a characteristic to have a 3D presentation element, like what we're seeing here on the bottom left of the screen. That annotation, which is floating in 3D space, and we could look at with our human eyes. But it's important to remember that that presentation element is for human consumption. That presentation element really is not essential to the definition of this characteristic within QIF. So other important elements would be datums and DRFs. These are types that are formally defined within QIF. So for example, with this part, we have a position and a size of this hole here with respect to datum AB, or datum reference frame AB. A is the bottom of the part and B is this hole. So the way that this looks like in terms of the structure is we'll have a characteristic, which is the size tolerance. That'll point to that hole, which is being controlled. And then we have the position tolerance. The position tolerance will also reference that hole, which is being controlled. But then additionally, it references a datum reference frame structure. So we have our datum reference frame. The datum reference frame references each of the datums, and each of the datums in turn references each of those features, this bottom plane A and this hole B. So that's a little bit how internally some of these data structures are organized in order to specify a position tolerance with a datum reference frame, for example. The next important element that we have is one of the QIF application areas. So this would be another element that could be specified at the top level, right below a document, a QIF document element. And this would be the product. It's more colloquially known as the QIF MBD, or the model-based definition. But this is where the CAD and the PMI is expressed. And this is the way that you could take these abstract ideas of features and characteristics and tie them to the product definition, your product definition that you'll have, stored in your PLM system. That will be how this is tied together, is by using the QIF MBD. So, really part of the idea of why this is part of why this is an important element of QIF is that this is, we talk about the idea of digital twin, which is maybe this concept that many people have heard of. That's kind of the purpose for this whole application area, is to provide the glue to tie the quality data back to the actual product definition. The next application area that we have, which is also an element which can exist at the top level, is the plans. And so measurement plans can really be expressed at various levels of detail. At the highest level of detail, we might have what's called often the bill of characteristics. And that's basically, what is it that we're measuring? Usually this whole ballooning process is part of what we talk about with the bill of characteristics, where you balloon the tolerances that will be measured, and that's it. It can also get much more detailed, where you can specify, okay, here's what I need to measure, but here's how I'm going to measure it. With this piece of equipment, I'm going to use these sampling points, etc. Down to some pretty specific, detail. And the range could be anywhere between. You could specify criticalities to tolerances. Specifying that this tolerance is a major criticality and I'd like to measure it, for all measurements. This is a minor criticality and I'm only going to measure this for my first article inspection. Things like that. The next application area that we have is results. This is obviously a very important one. And this is how measurement results are collected from real data and how those results are tied to the nominal, to the nominal definition of the feature, and also optionally to the model. The results can be pretty highly organized. They could be serialized. You can be capturing data on serialized parts, and the results could be tied to those serial numbers and so forth. There's a lot of structure in here for gathering very detailed information about the results. Next, we have statistics. And there are a couple different ways in which statistics can be used, the statistics element. One basic way is simply saying, when we gather statistical data, when we gather results, these are the SPC rules that we want to apply towards those results. The other application would be to actually carry out SPC, some SPC process or some SPC control on a set of parts, and to kind of bundle those parts together and indicate what the result of that SPC calculation was. Next, getting into resources. So this is another top level element, is the measurement resources. This is a way of specifying measurement equipment. And so the idea would be that you might specify that we have so and so set of calipers with such and such a range, such and such an accuracy. We have such and such a CMM with some certain ISO 10360 performance test results, certain gauges, certain probing systems, et cetera, et cetera. A huge range of devices is supported with this. It's a pretty complete set of measurement result types that are expressed in this set of data structures here in this whole resources area. Next, we have QIF Rules, which is kind of a forward-looking application area for QIF, an area where a lot of people are trying to go. And it's sort of a way of expressing either best practices with measurement or measurement templates, or certain measurement standards that an organization might wish to employ for their measurements. The way in general that it works is kind of like, for those that do any software programming will recognize this. If some Boolean condition, then carry out some action. The types of things that could be checked are things like the tolerance type, the tolerance value, the type of feature that it is, like if it's a cylinder or a plane, the size of the cylinder, if it's a feature size, is the feature a datum? Is it an internal or external feature? Like, is it a hole or a pin? It's possible to define user-defined sampling categories, like high density, low density, and use those to help define measurement protocols. And actually, there's a pretty robust way of carrying out the user putting together their own arithmetic method for carrying out some operations. So here a simple one would be the surface area is greater than or equal to 150. It's also possible if you wanted, you could say, well, the surface area divided by the depth of the hole must be greater than or equal, if that's greater than or equal to the diameter of the hole, then carry out some action, whatever. And then the actions that can be taken based on the result of that Boolean operation. You'd have the sampling point count that you want to use, the density of the sampling points that you want to use, the sampling strategy or sampling pattern that you want to use, the fitting algorithm that you'd like to apply when evaluating the tolerance, the measurement equipment that you'd like to use to carry it. And actually that latter bullet point is probably the one that is one of the most pursued at this point. The selection of measurement equipment based on certain criteria. Actually, with this, I think let's jump to the other poll. Ray, you want to bring that up?
Yes, the second poll is, what application area of QIF do you think that you would start working with at first? MBD, plans, rules and statistics, rules and resources.
So yeah, we kind of grouped these together a little bit because I think we're only given four options for the poll, but that'd be an interesting thing for us to see is just what some of the different application areas are, which ones are some of the most attractive or which people view as the lowest hanging fruit.
Can I add one thing about rules?
Yes, yeah, please. Yeah, this is Tom Kramer from NIST.
Yeah. QIF provides a mechanism for writing rules. QIF does not provide the rules themselves. You have to make your own set of rules or borrow somebody else's set of rules. But QIF only provides a mechanism for writing rules.
So we have about 65% of the votes in. We'll give it another minute here. If you could please vote now.
All right. Well, I think let's
see the results.
See what everyone's saying here.
Oops, let me share. There you go.
All right, so yeah, so I guess MBD is one. I mean, I think model-based enterprise is obviously a very big field of interest for people. And then results and statistics, I think that's right. Yeah, I mean, gathering of intelligent data, I think it's a big topic. It's a big topic for people. So yeah, well, thank you, Ray. So we're kind of moving on to a little bit of a different area now. So I wanted to give a little bit of background about the modularity of QIF data. Basically, the idea here is just thinking back about this original slide here about the major QIF elements. And the first one that I mentioned, the QIF document, this top level element, which can store things like the product, the MBD, the features, the characteristics, the results, the measurement resources, the data reference frames, all those things that I was just talking about. The way that QIF is designed is it's designed such that QIF files can reference other QIF files. And this is actually a very important part of QIF because in any non-trivial application or implementation of QIF, this is something that's going to happen. It doesn't make sense to have to provide all of your data in one single instance file. So when you think of QIF data, you shouldn't necessarily think of it as something where it's just a single QIF instance file and that's it. That instance file by itself has all the data that you might need. It's definitely very common that instance files could reference other files. So let me give an example of what I'm talking about. Here's a little workflow where each of these boxes would represent a separate instance file. Okay, so maybe the workflow would be we'd start with the MBD part, and this would be something that would be like the CAD and the PMI, which mirrors your native NX or Creo or CATIA model. So you have your CAD and your PMI. From here, you will use an externally defined resources file and an externally defined rules file to come up with your plan. So somewhere else, you'll have a definition of all the resources that you have available in your arsenal of measurement resources. And then you have some corporate standards for how you carry out measurement. You use those along with your MBD and you generate a plan, which could be a separate file, like a separate instance file from your MBD. And then from there, you go and you manufacture some things, you measure them, and now you have, let's say you manufacture 10 items, 10 articles, so you have 10 individual QIF results files. You might have a separate QIF statistics file, which references those, and the plan could reference those statistics. So here we have 15 separate instance files, which all sort of form part of one cohesive QIF workflow. So that's so that this is what I mean by sort of a federated data model. Now, one other thing though that's worth bringing up with this picture is the way this picture is laid out is also a bit simplistic in the sense that, oh, this is an MBD file, this is a resources file. This box right here calls out the fact that, a single QIF file can have instantiations of multiple different types of elements in it. So it doesn't, asking the question, is this a QIF MBD? Like, oh, you just emailed me a QIF file. Is it a QIF MBD file or is it a QIF plans file? And that is not a question that always makes sense because the answer is it could be both. I mean, really the question is, does this QIF instance file have product data in it, QIF MBD data in it? Does this QIF data have measurement plan information in it? That would be the QIF plans. Does it have measurement resources information in it? If it does, then it has resources and so forth. It's also possible for QIF to reference non-QIF files. It can reference external files. So here is an example that's like a fairly, I guess you could say, it's a simple looking model, but a fairly sophisticated example of an assembly expressed in QIF. This would be product data. And all of the CAD is actually expressed inside of a JT file. So it would be this would be a way to tie QIF-based data to a JT-based workflow, for example. But so this is an example of externally referencing non-QIF files. So a little bit, these are some of the final slides, but getting a little bit out of the pure theory of things, I thought it'd be good to end a little bit on the more practical or application side of QIF. With the question being that, so these are nice, these are some nice designs, but in the meantime, there is a robust system that is employed at most organizations of using PDM software to organize their product data, and hopefully the idea being that their manufacturing operations should flow from the data in that PDM system as well. So how does QIF fit into that paradigm? So I think the answer that we typically see is something like this. So we'll have this green box would be sort of what's contained inside of a PDM software package. And by the way, this that I'm going to give is one example of how something could be done. But so this green box would be your PDM software. And so you'd have in here your native CAD model, your Rev 1 of your native CAD model. That could be, like I said, Inventor, SolidWorks, CATIA, NX, Creo, whatever you use. From there, you would have a derivative model, which would be your QIF MBD model. The QIF MBD model would reference the native CAD, and it would have tiebacks to, at a low resolution of, this position tolerance here in the QIF model corresponds to this PMI entity on the native model. So a real low-level mapping of the QIF data to the authority product data. And then from there, you might be gathering all kinds of other, or you might have all kinds of other data that references it. You know, maybe QIF results, maybe QIF plans, statistics, and so forth. This data very likely will actually live outside of your PDM system. You know, measurement results data, you might not want to be pushing this up to your Windchill or Teamcenter system. You might want to be storing this in some other form of a quality data system. And that's okay. Those QIF results files can reference this QIF MBD file and keep the mapping between the result for this position tolerance on this part serial number tie back to this item on the authority CAD system. And this workflow can go on and on, where you'd have Rev 2, you know, all the way down to Rev N. You can keep collecting, you know, results and plans. There could be associativity and sort of understanding of, you know, what has changed and what has not changed between the revisions. In order to, you know, if you wanted to look at, you know, let's say the diameter of some hole that has not changed at all from Rev 1 to Rev N, you can look at the results from all of these revisions and do some type of analysis there. And then I guess, yeah, the final thing is that in general, the idea is that, you know, the basic idea is that this model, this QIF MBD model, should be an exact mirror of your authority model. I mean, this is especially important in a model-based, in the field of model-based enterprise, where you're using your model for so many important, crucial things. It's very important that the model is true. So typically speaking, I mean, these are some of the practical aspects of how QIF fits within a PLM world. And again, it's just sort of the fundamental idea of keeping that authority CAD model as the single source of truth, and then from there, spawning QIF data and making sure that the mapping is always intact. I mean, again, you know, going back to this term digital twin, which is, you know, used quite a bit, this is really, you know, the purpose of what QIF is trying to achieve, is this ability of being able to tie quality data back to the product, the authoritative product definition in PLM. And yeah, I think we have one more question, Ray.
Yes, we do. Let me launch that.
Okay.
Question is, will you be attending Tom Kramer's QIF 3.0 Coding QIF Applications webinar next week, same time? And yes, definitely, or no, sad to hear that that's not going to happen. Polls are open.
That's maybe a little bit of a leading question, but yeah. So next week is Tom Kramer's presentation, where he's going to be getting into the source code bindings that are available for free, open source source code bindings that are available on our Git page, our GitHub page. And he's going to be giving some background on, you know, how they work, how to generate applications with them, and yeah, how to get into the idea of doing some software development using QIF. And it's interesting because you know, this could be a utility for, you know, professional software companies, but actually, you know, it could definitely be a tool that's useful for end users as well. You know, it's not uncommon that you know, most engineers these days are pretty good with Python. And so doing doing some basic Python programming for, you know, some QIF hacking is something that's might be easier than you might think.
So we have about 75% of the people have voted. I'm going to give it about another 10 seconds. If you haven't voted, please vote now. And close the voting. And it looks like yes is a winner.
All right, good.
All
Okay,
right.
Well, so yeah, so now, now it's time for questions. We have some questions that we've collected here, and so maybe we could just go through some of this.
Do you want to read them?
Yeah, let's see here. So. Yeah, so okay, here's one. In the world of design engineering and legacy design systems, some features or tolerances might be defined in a specification like a paper document. And how does QIF account for this, or how could they be linked? So it's a good question. And QIF we did our best in trying to support legacy systems whenever we could. So for example, the common way that you see QIF in terms of its tie back to the product is using CAD, the QIF MBD, but it's actually also possible with QIF to reference a drawing. Now the drawing, the reference back to the drawing would not be as let's say semantic as you might expect with MBD, but it might say, you know, here's a characteristic, and you'll find it on the drawing on page 3, grid A4. And that's, you know, so things like that were done in order to support, you know, a QIF-based workflow using a legacy system. And so I believe that the same type of thing is possible. So there are user-defined, or possible with characteristics, which I think would be the relevant area for this question, that it's possible to define user-defined characteristics and source an external document as the source of what that is, and it might be, you know, spec ABC 123 paragraph 15.4, and that's the characteristic that you're using to control, you know, this hole right here, for example. So yeah, so the idea is that that a legacy workflow would is meant to be supported. And actually, yeah, I mean, maybe Ray, if you do want to go through some of the other questions, and I'll go through some as well.
So there's a question, does QIF geometry allow closed surfaces, i.e. a face is made of a closed cylinder, not two halves of a cylinder?
Yes, it does, yes. And you would see such a thing. I think in that image that was shown earlier, I think that came out of Creo. And so Creo, their modeling kernel will model in such a way. But the idea behind, part of the idea behind the idea of QIF or the design of the QIF product area, the CAD area, is that it should support the different geometric representations that are done or that are used by the various different CAD systems and CAD kernels that are out there. So yes.
Well, this one seems to be associated to that too. In the world of design engineering and legacy design systems, some features.
Yeah, that's the one. That's the one I answered at first.
Okay, sorry.
Let's see. Here's a good one. So product engineering creates an MBD using whatever CAD system they have. Then they translate that MBD into a QIF MBD, which allows them access to many QIF applications that will pool some of that data into the QIF standard. So the question here is, what is the single source of truth? The CAD, you know, the native CAD MBD or the QIF MBD? And who gets to blame if that translation didn't occur correctly? So I think the answer here, practically speaking, is it's going to be the native CAD MBD. So, you know, your NX model or your Creo model or whatever, that's going to be the authoritative product definition. It's a very robust tool for creating excellent designs. And the idea is that the QIF should always mirror that. And so So this second point that's brought up, I think, is good. Is who gets the blame if that translation didn't occur correctly? Well, I don't know who would get the blame, I guess, but the important thing is that it becomes crucial that that translation is done correctly. And so, but really, it's the same thing for even if you take forget about PMI and just think, let's say, a step model without PMI. If you're going to use that to in CAM software to create a cutting path, you better hope that that step model is correct and is accurate, because if it's not, you're going to have built-in error to your product before you even start cutting metal. So yeah, I think it's a very good question.
Okay. How about the one? How does QIF manage rules created by a company? So unique customer rules.
Can I answer?
Yeah, sure. Yeah, Tom.
QIF does not manage anybody else's rules. The company has to manage its own rules. You can put your rules into a QIF file, but then you're responsible for dealing with them.
Yes.
And then the next question, which is kind of like this, I think, how can you use QIF results and statistics without using QIF plans beforehand?
It is possible. I mean, so QIF results and statistics will depend on elements in the library, like basically features and characteristics. The features and characteristics are technically defined inside of the library, and so the results and then therefore the statistics would use those elements that are found inside of the library. I would also say that I think to a large extent it's probably a good idea not to get too hung up on the formal definition or the terms, plans and results and statistics and things like that, because the line between them all is not always exactly 100% clear. And I say that because the large majority of the QIF schemas are defined inside of the library, what's called the library. So when you download the schemas and look at them, you'll see that the two folders that contain all the schema files, there's one called Applications, and then there's one called Library. And the applications will have results, plans, product, measurement resources, rules. What am I forgetting? But those, and so there'll be some schema there. But then inside of the library, there are, I don't know, maybe Tom, what is it, 25, 27 library?
15 in the library and 7 in the application.
Okay, so I would say if you count the number of lines of schema code, there's probably quite a bit more, substantially more in the library than there is in the application area. And that's simply because there's there are a lot of the data structures, the core data structures that define QIF, that are used by many different application areas. So it's not like there's always a clear line between them. In other words, at the end of the day, you're using QIF data to achieve some certain goal. So.
Yeah, if you have a QIF results file, it's almost certainly going to be full of features and characteristics also.
Absolutely, yeah. Again, going back to that, I would say QIF features and characteristics are kind of the core of QIF. I mean, that's really one of the most important. That's kind of at the heart of QIF. Go ahead.
One more question here. We want to respect the hour here that we were committed to. Here's one more. Just rules. Under rules, is it possible to specify filtering options and number of points?
Number of points, yes. Filtering options, I don't think so, actually. Tom, do you agree with that?
I'm not sure exactly.
I guess that means, I think the question is about filtering of points, like especially with scanning applications.
Inspection.
Yeah, high density scanning, point cloud scanning, where you'd filter the points first.
Oh, yeah.
I don't know that is addressed.
No, but you do have fitting algorithms, but I don't think we have filtering algorithms.
At this point in time, we're always looking for opportunities to extend. I think the rules section is one of the areas that we could expand based on different measurement resource types and how we might use those. So this is Curtis Brown speaking.
Okay, and then one question here, I'm along with the person. Not all, it says not all QIF files refer to a single qubit, but each result file should have a qubit identifier. So that's the question: is qubits always associative to all the files that get generated?
Yeah. So a the type, which is called a qubit, it's an element called a QPID, is really just a UUID, which is an ISO standard mechanism for creating a random and unique number. Practically speaking, statistically speaking, it's guaranteed to be unique until the heat death of the sun. And that's the tool that's used to create one of these qubit IDs. Those are associated they can be associated at various different places in the QIF model. Each document has a mandatory tag for a qubit. So it's required that you have to generate a UUID at the QIF document level, at the top level document. And that will make sure that that instance file that you have can be addressed as a unit, uniquely throughout the universe. And then within the QIF file, there are different ways of addressing different pieces of data. There are basic simple integer IDs that are assigned to all the key elements within the QIF file that will be unique within that part, or within that file, that instance file. And so between the UUID of the document and the internal ID, you can get a unique handle or a unique address on any piece of low-level QIF data that you want. And then for more sophisticated workflows, you can actually tag various key types like certain features and characteristics and so forth with UUIDs themselves if you want to track them as their own separate entity throughout your enterprise workflows.
Okay.
So this is Curtis. I might just add, there is a lot of options for QPIDs, but for those that want to have good traceability, we would encourage you to use the QPIDs where appropriately, especially as a digital thread.
Okay, I'm going to do the last question here, and then we'll close the webinar today. So this person asked, what competencies do I need in my company to implement QIF-based workflows?
Yeah, no, that's a good question. So I think to a large extent, I think that the answer to this might be a little bit different depending on if you're a larger or OEM that's kind of organizing a lot of the enterprise data workflows, or if you are part of a supply chain that's kind of part of an organized enterprise workflow that would belong to your customers. But at the end of the day, there are two ways to use QIF. I mean, the biggest way is going to be that you use software applications that use QIF, that you're not using it directly. Most people are not software developers. Instead, they're using some software applications that will use QIF. And so that would be the number one way. And for the most part, this involves the use of more sophisticated software tools to carry out digital engineering. And so I guess at the broadest level, competence with digital engineering is what's going to help you really succeed if you want to use QIF powered tools. The second way people could use QIF, and people do use QIF, which is probably, definitely much less common than using software, professional commercial software applications, would be to generate your own software. And this is usually much simpler software, usually just sort of scripts to pick some data out and, maybe publish it to a server, or, whatever, simple tasks like that. But it's definitely something that could be done with relative ease by larger companies, and it is done. And that's a little bit what is going to be discussed in the next webinar when Tom Kramer talks about developing, some basic applications to read and write QIF. But QIF definitely makes that very easy to do.
So I'm making that the last question. Thank you, Daniel, and the rest of the panelists on today. This concludes today's presentation on QIF 201. And a reminder that next week we will have QIF 3.0 coding QIF applications with Tom Kramer. We will be sending out an email in the next 24 hours with links to this webinar, copies of the presentation slides in PDF, and contact information if you have any additional questions. Thank you and have a great day today. Thank you.